Hello GATE aspirants, welcome to part 15 of GATE Thermal and Statistical Physics series. Question number 14. If a thermodynamical system is adiabatically isolated and experiences a change in volume under an externally applied constant pressure, then the thermodynamical potential minimized at equilibrium is. Here first option is enthalpy. Now enthalpy change dH can be written as this is equal to TdS plus VdP. Now here it is given that it is adiabatic process, that means dq is equal to 0, that means change in entropy will be 0, and also this is at constant pressure, so dp is equal to 0. So ds is 0 and dp is 0, that means this gives us dh is equal to 0. So this function will be minimized. Next is Helmholtz free energy, df is equal to minus pdv minus sdt. Here volume is changing, so this won't be 0. Then we have Gibbs free energy, dg is equal to vdp minus sdt. Since here there is no change in pressure, with change in volume temperature will change. So this will also not be equal to 0. And grand potential d phi is equal to minus sdt minus pdv minus ndv, where mu is chemical potential. So here again volume is changing, so this won't be 0. So option A is correct. Next question. The vapor pressure P of sodium solid ammonia is given by ln of P is equal to 23.03 minus 3754 upon T, while that of liquid ammonia is given by 19.49 minus 3063 upon T, where T is the temperature in Kelvin. The temperature of the triple point of ammonia is. Now at triple point vapor pressure will be same. So these two we can equate, and from here we can find out value of T, and value of T comes out to be 195.1977, which can be rounded off to 2 decimal places as 195.98. 19, so that will be 20. And the answer given in the answer key for this question is 195.10 to 195.30. Next question. The canonical partition function of an ideal gas Q of function of temperature, volume and number of particles is 1 upon n factorial V by lambda cube raised to n, where T, V, n, lambda denote temperature, volume, number of particles, thermal de Broglie wavelength respectively. Let Kb be the Boltzmann constant and mu be the chemical potential. Take ln of n factorial is equal to n ln n minus n. If the number density n by V is 2.5 into 10 raised to 25 per meter cube at a temperature T, then E raised to mu by kBt upon lambda cube into 10 to the power minus 25 is dash meter cube. Here partition function is given to us. Here Q is equal to 1 upon n factorial into we have V by lambda cube, this whole thing raised to n. So from here I can write partition function for grand canonical function, grand canonical partition function. So this will be summation over n e raised to beta mu n into this q. So this will be equal to, z will be equal to summation over n. Here we have e raised to beta mu n, and this q is equal to 1 upon n factorial into v by lambda cube whole thing raised to n. Now this can be written as, this z can be written as summation over n, and we have denominator n factorial, and in the numerator we have this whole thing and this is raised to n. So this we can write as e raised to beta into mu into v by lambda cube and this whole thing raised to n. Now we know e raised to x is equal to summation over n x raised to n upon n factorial. So this is similar like this. So we can write this as exponential of v by lambda cube into exponential of v mu. So this can be written like this. Now from here we want to find out the number of particles. So this is partition function, and then grand canonical function will be minus kbt of ln of z. So this will be equal to minus kbt ln of this. So this exponential will disappear. So this will be v by lambda cube into e raised to beta mu, and n is equal to minus of dou omega by dou mu, and this will be at constant temperature and volume. So this will be equal to minus dou by dou mu of minus of kbt v by lambda cube into e raised to beta mu, and this is equal to minus minus n will cancel out. This is kbt into v by lambda cube into e raised to beta mu, and with respect to mu we are differentiating, so into beta. Now we know beta is equal to 1 by kbt, so this will cancel out. So from here we will get n by v is equal to, this v I am taking on the left hand side, this will be e raised to beta mu by lambda cube, and beta is 1 by kbt. So this is the part. So this will be e raised to beta, or this I can write mu by kbt upon lambda cube. This will be equal to n by v, but n by v is 2.5 into 10 to the power 25. And on the left hand side we also have 10 to the power minus 25. So by multiplying this we will get 2.5 here. So answer is 2.5, and answer in the answer key is also 2.5 to 2.5. Next question. Consider a three-dimensional system of non-interacting bosons with zero chemical potential. The energy of the system E is proportional to k square, where k is the wave vector. The low temperature specific heat of the system at constant volume depends on the temperature as Cv is proportional to T raised to n by 2. Then the value of n is. Now here it is given that E is proportional to k square. Now G of E, it is proportional to E raised to d by 2 minus 1, where d is dimensionality. So here dimension is 3 dimension. So this will be e raised to 3 by 2 minus 1. So that is 3 by 2 minus 1 is 1 by 2. So this is G of E, that is density of states. So we can write this like this, some constant A, e raised to 1 by 2. And we also know Fermi function f of E is equal to 1 upon e raised to e minus mu by kt minus 1. So this is Fermi function. From here we can calculate energy. So energy is equal to, total energy will be equal to 0 to infinity, and then we have E and f of E into G of E d, GED. So we can substitute these values and calculate this. This will be 0 to infinity. E, GED is A into e raised to 1 by 2. Fe is this, and here it is given that it is 0 chemical potential. So we can write mu is equal to 0. So this will be e raised to e by kt minus 1 into we have de. So this will be, u will be equal to 0 to infinity A e raised to 3 by 2 and e raised to e by kt into we have de. Now here we will use Bose integral, where we have integral 0 to infinity x raised to n e raised to x minus 1. This is the case, then this is equal to, this is the Riemann zeta function, n plus 1 into gamma of n plus 1. Where this first part is, this is Riemann zeta function and this is gamma function, and this is known as Bose integral. So we will try to use this here. Here x is e by kt. So we have to adjust e by kt in the numerator as well. So we can multiply and divide by kt raised to 3 by 2 here. So this will be 0 to infinity, and here we have a into, I can multiply by kt raised to 3 by 2. So this will be e by kt whole thing raised to 3 by 2 upon we have e raised to e by kt, and this minus 1 is also there, minus 1, and here we have dE. So here I can multiply and divide by kt. So this will be dE by kt, and also I am multiplying by kt. So this is equal to u is equal to, this is a into we have kt 3 by 2 and this, so this will be 5 by 2, and then 0 to infinity integral, and we have here a by kt raised to 3 by 2, then e raised to e by kt minus 1, and here dE by kt. So we have adjusted the derivative part. So from here we can write this is equal to a into kt raised to 5 by 2 into, this will be a zeta function of n is here, n plus 1. So this will be 3 by 2 plus 1, so that is 5 by 2 into gamma of 5 by 2. And these two functions will give us number. So from here we can see u is proportional to t raised to 5 by 2. And Cv is equal to, Cv is derivative of u. So dou u by dou t. So if t is proportional to 5 by 2, then this will be proportional to, this will be 5 by 2 and t raised to 5 by 2 minus 1. So that is 3 by 2. So Cv will be proportional to t raised to 3 by 2. So here n is equal to 3 you will get. Also you can solve this question by using this shortcut. If it is given that omega is proportional to k raised to s, then this density of states rho omega, it is proportional to omega raised to d by s minus 1, where d is dimensionality of that system, and internal energy u is proportional to t raised to d by s plus 1, and Cv is proportional to d by s. So here d is 2, this is given to us, and d will be 3. So directly also you can conclude that Cv is proportional to 3 by 2. So answer here is 3, and answer given in the answer key is 3 to 3. So these were all the questions from GATE 2024 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.